unit factor and where the numerator and the denominator are going to equal each other. For example, we can say 1 foot over 12 inches because those two are equal to each other. You'll notice that the same conversion factor is written on the right side, however it's flipped. There's a reason for this, and we'll see why when we start doing some examples. These aren't the only examples of unit factors. There's lots of other types of conversion factors or unit factors that we can use. A unit factor is simply a relationship between two values that are equal to each other. So for example, in terms of density, if you have an object that, let's say, has a density of 5 grams per milliliter, this is another example of a unit factor because you're saying 5 grams is equal to 1 milliliter of that particular object. Let's say you have a rate of pay of $10 per hour. This is another example of a unit factor because it is a relationship between time and your wage. In this video lesson, we're going to be looking at the process of dimensional analysis. This is a very important concept because we'll be using this process throughout the remainder of chemistry. Dimensional analysis is simply using conversion factors to convert from one unit to another. So if you've ever been asked to convert one unit to another, let's say convert inches to feet or pounds to grams, you've done dimensional analysis. So what is a conversion factor? So dimensional analysis is simply going to use these unit factors to be able to convert from one unit to another. We're going to start with some simple examples, and then we'll go into some more complex examples. During the simple examples, we're going to set up the steps that you should use every time you do a dimensional analysis problem. So what I'm going to do is I'm going to minimize this screen right here, and I'm going to write the steps on the side before we do an example. All right. The first thing you need to do when you're doing dimensional analysis is you need to list out what is your given amount. This can be kind of difficult depending on if the problem gives you a lot of numbers. The most difficult thing about dimensional analysis is being able to pick apart all the information to determine what is your starting given amount. Once you do that, I like to say create a roadmap, and I'll explain what this means when I do an example. Finally, you're going to use conversion factors or unit factors in order to convert from one thing to another. All right, so let's start with a simple example. Number 1, how many inches are in 2.3 meters? This is a very straightforward dimensional analysis problem. The given amount that we're given is 2.3 meters, and so I'm going to list that out. Now, on the top of the page, I'm going to start listing my roadmap, and here's what I mean. I write the unit that I'm currently in, which is meters. On the right side, I want to write the unit that I'm trying to get to, which is inches. Then I ask myself, do I know a conversion factor or a unit factor, some sort of relationship that tells me how meters is equal to inches? Well, you may know one, but I don't. I don't know one that goes directly from meters to inches. But here's what I do know. I do know a relationship between inches and centimeters. That relationship is that there are 2.54 centimeters in every 1 inch. Then I ask myself, do I know a relationship between meters and centimeters? And I do. For every 1 meter, that's going to be equal to 100 centimeters. So by doing a roadmap, I can now easily see how all of my numbers and units are going to be related to each other. So now that I know that, I can continue setting this problem up using these unit factors. Here's what I do. And I'm going to rewrite 2.3 a little lower so I have some more space. I know this problem is going to take 2 unit factors. Here's one and here's the other. So I'm going to set these up. There's the first one and there's the second one. Here's the trick. Do not put any numbers in yet. Instead, just start by putting your units in such a way where they cancel out. They need to be in the numerator in one spot and then denominator in another. So since meters is on the top right here, I know meters needs to go on the bottom here. Centimeters then will go on top, and that will take care of this conversion right here. The meters will cancel out, and I'll be left in centimeters. Now to cancel out centimeters, centimeters needs to go on the bottom in the second unit factor, and inches will go on top. That'll make centimeters cancel out, and therefore my second conversion factor is taken care of. Now that I have the units in place, go back through and put the numbers in the correct spots that would make everything equal to each other. 1 meter is equal to 100 centimeters, and 2.54 centimeters is equal to 1 inch. Now everything's set up in order for me to calculate. What I'm going to do is I'm going to calculate everything across the top. 2.3 times 100 times 1. That's going to give me 230 across the top. On the bottom, I have 1 times 2.54, so that would be 2.54. When I divide 230 by 2.54, this is going to give me my answer. Since this is my answer, I now have to do my correct significant figures. Taking a look at my conversion factors, I see that 2.3 is two significant figures. I'm not going to base significant figures off of this conversion factor because this is just simply metric conversions. Those are exact numbers. And I'm also not going to base it off of this conversion factor because this is, remember, is an exact conversion. There's exactly 2.54 centimeters in 1 inch. So the only significant figures limiting our problem comes from the 2.3. And so my answer with correct significant figures would be 91 and my unit would be inches. All right, let's take a look at another example. All right, my second example here is convert 54.5 miles per hour to meters per second. So doing just what I did before, I'm going to start out writing what I'm given. Now this is an example where I have what's called a double unit or a derived unit. So I have 54.5, the miles goes on top, and then the hours goes on the bottom. When we say per hour, it's assumed to be 1 hour. All right, so we have two units going on here. We have miles per hour, and we want to convert it to meters per second. So we need to convert the top unit and the bottom. Let's look at the top unit. Do I know a direct conversion to get me from miles to meters? I don't know a direct conversion, however, the problem does give me some useful information. I do know how to get from miles into kilometers using the conversion factor it gives me in the problem. And once I'm in kilometers, I then know how to get to meters. So now I have a roadmap that'll help me convert the top unit. What about the bottom unit? You may know how many seconds are in an hour, but for those that maybe don't know, let's convert from hours to minutes and then from minutes to seconds. So to do this problem, it's going to take a total of 4 conversion factors. 2 for the top and 2 for the bottom. So I'm going to rewrite out, actually I'm just going to move this over, there we go. I'm going to set up my conversion factors next to my given amount. So there's 1, 2, 3, and 4 conversion factors that it's going to take to do this problem. You have to convert both units, top and bottom, so it doesn't matter which one you choose first. I'm going to go ahead and choose the converting the miles. Remember, don't plug in any numbers until you know what units are going where. So I'm going to put miles on the bottom so that it cancels out, and I'm going to kilometers in order to take care of the first conversion factor right here. Once miles cancels out, now I will convert from kilometers into meters. The kilometers will cancel out, and this will take care of the second conversion factor. Next, I'm going to convert the hours. Since hours is on the bottom, I have to make sure it's on the top over here so that way it'll cancel out. And I'm going from hours to minutes. This will take care of the third conversion. And then finally, minutes will go on top and seconds will go on the bottom in order for minutes to cancel out. And that'll take care of that fourth conversion. And so now hours will go away and minutes will go away. And therefore, I will be left with my 2 units that I want, meters and seconds. Now we can plug in the numbers. For every 1 mile, it's going to have approximately, if we go back over to the problem, 1.6093 kilometers. So I'm going to write that in here. All right, the next conversion is a metric conversion. For every 1 kilometer, that's going to be equal to 1,000 meters. For every 1 hour, that's equal to 60 minutes, and 1 minute is equal to 60 seconds. Now we just have to multiply through and round our answer to significant figures. When we look at our answer and how it should be rounded to significant figures, we looked at there's 2 values that's going to limit our sig figs, the 54.5 and the 1.6093, since both of those are not exact numbers. Every other conversion used was an exact number. The 54.5 is the lower of the 2, being only 3 sig figs. And so my answer in 3 significant figures would be 24.4 meters per second. All right, let's look at our last one. The last one here says how many 375 milligram tablets can be produced from 2.60 kilograms of powdered aspirin. All right, so we have two numbers going on in there. Which one do we start with? Start with the one that you know you have concrete information about. So 375 milligrams is the mass we know is in one tablet, but does that really tell us how many tablets we have? It doesn't. The only thing we know for sure that we have is we're given 2.60 kilograms of powdered aspirin. So that's going to be the number that we start off with. And so down here, I will write that out. 2.60 kilograms of aspirin. All right, now we're asked to go from kilograms to how many tablets. So let's set up our roadmap here. I'm currently in kilograms. Oops, there we go. I'm currently in kilograms, and I want to get to a quantity of tablets. All right, there's no direct conversion here, but I'm actually going to work backwards on this one. What relationship do I know between number of tablets as I try to inch a little bit closer to kilograms? Well, I know that there's 375 milligrams for every one tablet of aspirin. So I actually do know a relationship between milligrams and number of tablets. Now that I am in milligrams, the next conversion is just simply going to be from kilograms to milligrams, and this is going to be a metric conversion. So this step can be done in two conversion factors. So let's set that up at the top. There we go. So let's place our units first so that way everything cancels. Kilograms on the bottom to milligrams on the top. This will make kilograms cancel, therefore taking care of our first conversion. Once we're there, milligrams will go on the bottom and tablets will come on the top. That will take care of the second conversion. Now we can place our numbers. For every one tablet, that's going to be equal to 375 milligrams. And then let's take a look at the conversion factor for kilograms to milligrams. The kilogram is the larger unit, so I'll put a 1 there. And then if I look at my metric mnemonic device of Mean King Henry, kilogram to milligram is 6 spots. So that's 6 zeros, or you can just say 1 times 10 to the 6th. Now everything is set up to cancel out, and we'll be left with tablets once we calculate our answer. As I look to my significant figures to write my answer, 2.60 and 375 are the two numbers that are measured. Both of those have 3 significant figures. And therefore my answer will be 3 significant figures, which will be 6,930 tablets. Or you can write it 6.93 times 10 to the 3rd tablets.